Okay. I forgot. 1 second. This computer messes up if I don't use that thing. All right, so let's write this one down. Let's try it out. So you just want to make us, you want us to make the picture. So 5.4. So U is the big universe. A through, well, actually, no. So write them down, I guess. A, B, D,
E, F, A, M, N, D, X.
P, X, Y. Okay. Okay. Write these down. So each of these sets, A, B, C, would just be its own little circle. So just draw a circle for each one. And make sure they all overlap. But it is possible that sometimes they don't overlap. So we guess we should check it. Switch back to the screen. So they want us to create a Venn diagram using all this. So it helps to have the intersections so we know like, where they overlap. So we got to do those first. So A intersect B, they have in common. A and B has A, and then D, right? That's it. I don't see any other ones.
A and B.
Okay. Now we do A intersect C. Do they have anything in common? You see? A, E, F.
F.
Is that it? Okay, last one. B intersects C. So this is all three sets intersected together. P. That's it, right? Okay. All right. Let's see here. Make our big box here for the universe U. Probably too big, but it's not good. So one circle for A, another circle for B, one more circle for C. All right, so let's do the intersections first. So, oh, we should do one for all three. Forgot about that. A intersect B intersect C, because we got to see what goes right in the middle. So what do they all have in common? All three have A. Anything else? All right. So the triple intersect is just the letter, the element A. So that goes right in the middle. Triple overlap. Okay, so that's taken care of. Now let's see what's in the middle of A and B right here, but not including the A because that's already inside. See that little this section right here is A intersect B. Right. So I already have the A, so just D goes here, right? Because A and D go right there. This section is this. Right? See how that overlaps right there?
Yeah.
The middle though is also this one at the same time. So this section in the right in the middle is this, but this bigger piece is A intersect B. So down here we have this section here, right?
That would be
Yeah, this is B intersect C. So of course,
P, right?
just so yeah, in this part right here, it's just the P. Because A, we already took into account A. All right. Now A intersects C. EF is outside of B, right? So we don't put it in that B overlap. Okay. So now we can look at the individual ABCs. So what's inside A, but not in anything else? Yeah, B, right? What else? D's right there. Yeah, that's it, right? Okay, so what's inside B, but not anything else? And K. Okay. Now what's inside C? But nothing else. Just the X, right? Okay, so now we got all the three circles done. But there could be stuff outside of those three circles because ABC may not have taken everything into account inside the U.
So everything else is not in the ABC.
Yeah,
So
so
M,
yeah, M's going,
Y.
Y. That's it, right? Yeah. So this is the big set U, right? So A and B are living inside the U, ABC. These elements are inside those sets, but this guy, these two are outside. Yeah, does that make sense?
It really is, yeah.
So yeah, so this question here, 2 and 3, they want you to create the circles and put the stuff in the right spots. Over here,
They wanted me to find out what,
yeah, we found the intersections without drawing the sets. So it's more like understanding what intersection means in union. So now over here, you gotta go the opposite. So given the picture,
I get to write it out as the what we have originally.
yeah,
So we had to put the letters in the union, right? And
Mhm.
whatever's ABC.
yeah, exactly. So here they have the intersection. So you have to understand what is the intersection mean? What is A exactly? Yeah, let's do that one next. Are you cool on this page though? Okay. So you got the picture in front of you. Right? So part A, this is example 4, says find set A. So everything inside the circle A, we just write it down. So we got what? X, P, R, S, E, G, B, F, R, S, B, F, E, G, X, P. Got them all right?
What else for A?
Yeah, everything inside A, so circle A. So all of these are inside the A, right? So now the next one, all right, so I wrote down the elements that were in that circle. That's it. So A intersects C is what they have in common. So visually, right, it's just for the overlap together. So right here, the little section. So it looks like it's just going to be EG, BF. Right, you see it?
A intersects with PG. Yeah.
Mm-hmm. Yeah, that's that stuff right there. Okay. Now, B union C complement. So let's remember what complement means. And union, right? So B union C means you combine the two sets together. But complement means not those. So not the B and C combined. So look at B and C, right? Here's this big circle, B, and here's C. So they want everything outside those two circles. Everything outside of the B and outside of the C. Because I said B union C complement. So in other words, not B union C. For sure, QB, yeah. What else? XP, yeah. EG is inside C.
Oh, yeah, EG is inside C. So I think that'll be XP and Q.
Yeah, that's it. So just make a little set. So B combined with C complement, so not this.
So whatever has like a complement, so it's sounding they want everything outside of it.
Yeah, whatever's the complement, just think not this outside. So they would have said a complement, and visually that means everything outside the A circle. D is A union B, then intersected with C complement. So this is a little hard to imagine all at once. But let's try. So it might be easier to find A union B first. Like write it down. So A union B is everything in A and the B circles, right? So let's write all that down on paper. Yeah, everything inside the A and everything inside the B. Just don't repeat anything. So this is A union B right here. X, P, E, G, R, S, B, F, W, T, M, N. Okay, and then they say intersected with C complement. So, okay, so I wrote down A union B, right? But they want us to intersect with everything outside of C. So yeah, so it helps to do it piece by piece because it's hard to envision all this at the same time. Everything outside the circle.
Without repeating, or we're gonna do XP,
Yeah, XP,
RS,
RS,
WT,
WT,
and QB.
Q, V. Yeah. So here's C complement, here's A union B. So what do they have in common, right? So intersection means.
R, S, W, T,
They're right.
put an LBM there.
Yeah, that'd be it. All right, that makes sense, right? Just do a piece, just do a first part and then the next part. That's example 4. I'm gonna skip 5 and 6. Let's go to 7. The 7 says, use the symbols to describe the shaded region. So basically, you see the picture and you write the symbols. So if the A and B were completely shaded, you would say A union B, right away. This is the whole thing. But they're removing that intersection. A intersect B would be the middle. They want to know the shaded part. So they want to know not that, yeah, the rest, I guess. So how do we write that? And there might be more than one way. I'm trying to find a. So A union B, but not including the intersection. So this is what I'm thinking. A intersect. Dang. I don't know. Hmm. Come back to that. Let's see this guy. Number 8. The entire A. Also A intersect C and B intersects C. Oh, I'm sorry. Okay. I thought they wanted it all at once. They just want each describe each shaded region. So not all of it at once. So I was making it harder than it was. I'm sorry. I was like, I don't know how I'm gonna figure this out.
So they want like a.
So let's do the left side first. So what would that piece be? It would be pretty big A intersect not B, right? Because we want nothing to do with B, that left. So I'm thinking for the left region, right? Left side. This guy, let me mark this in my annotation here. Just this, nothing else. It has to be A. Intersect not B. Because everything not in B that intersects with A would be this, only this section. Does that make sense? Can you visualize it?
Yeah, because asking if any comparisons be combined or combined, right?
Yeah, so
Complement.
we only want this, this little blue part right here.
And then to get the right side would be the other way around, would be B. Intersect A.
Yeah. So, because if you think about it, right, like, what does B have in common that's not an A? Well, that would just be the B. Nothing else. So yeah, it's a little outside the box. Getting a little harder now.
Oh, yeah, wants each.
Let's do each one, I guess. Let me see. 6. I'll just write it on here this time, a little easier. So so each region. So this part right here. That's gonna be A intersect not B, not C. So the blue is gonna be A intersect, so not the B and not the C. So it would leave me only with the A chunk. Let's see if I can use different colors. Now for this piece, I would use A intersect B, right? That gives me this entire middle part, but I don't want this piece. So intersect not C.
Also, keep anything to see out.
Yeah.
And then,
Now the middle one is pretty easy, right? Right, it's the triple intersection. Yeah. Okay. Purple.
intersects B but not B.
A intersect C intersect not B, right? You said. Yeah.
And then B intersects.
B, yeah, you're right. B intersect C, but not intersect with not A. Cool. Oh, so yeah, just make sure it's, if I read the question correctly, right? It's at each region. It was at all of them at once, and that becomes difficult. You're like, all right, how do I cut everything else out? You know, it can't. It'd take me like 30 minutes to figure that out. You're right. Like, oh, man, I don't care what that is. But anyway, yeah. You might want to put parentheses, but I think this is fine. But that's fine. All right. Well, that's 5-4. Fun. 5-5. They start applying this stuff, actual examples. So these can be a little. I mean, sometimes they can be a little weird to try to picture in your head, but let's work our way through it. Example 1, 5-5, page 63. So recent survey, they asked people if they like Star Trek or Star Wars. The results are given below. Okay. How many people like Star Wars? But there's also people who like both, right?
Yeah.
So we'd have to. Well, the question is, does this 256 include the 148? Can you tell? Yeah, because this one's bigger. So it likes, well, let's think about it this way. What's 148 plus 182? Oh, let's count it. Three-thirds. So it looks like it's not the total. So 330, I think, would be the total. I'm trying to make sure I understand how they wrote it. Let me read the question carefully. In a recent survey, respondents were asked if they like Star Trek and if they like Star Wars. So if it's a questionnaire, I'm assuming 148 people just checked Star Wars. 182 people checked just Star Trek. Right. And there was 256 that checked both. So I'm going to assume that each of those are separate things, not overlapping. So I want to say that part C right, scroll down a bit. Part C, I think it's just simply 148. plus the 256. Yeah, that's what I'm understanding. Let me check something first. Check out this homework problem. Can you see it from over there?
Yeah.
So similar to what we just talked about, we'll go back to that question in a second. They give us three regions, three sets, A and B, and they connect them together, right? They tell us there's I elements in this region, and there's 18 elements there, so they keep them separate. So when they tell you how many are in A, you just add them together. So it'll-
Something like 28.
yeah, so 10 and 18 is 28, yeah. So I'm trying to figure out if that's how they're writing it on that example. Like, are they keeping it separate, or are they not? Yeah, because otherwise the work changes, right? So let's find one that yeah, it appears that they tell you the number or the cardinality. Remember we talked about that, like the total elements in the set.
Yeah.
So each region is a total. Okay. So here's something similar to the question we were doing. A poll asks if they agree with the statement that college students should reserve a certain number of scholarships for minorities. Age 20 and up said agree. Okay. Yeah. Okay. Agree with the statement. Okay. So yeah, I think we're approaching it correctly. So look at this one. A survey of 200 students, 90 were taking math, 40 were taking psychology. What is the least number of students who could have been taking both courses? Let me look back at that example. So I'm understanding that this is a cardinality. I lost the page. What page was it? $60. That's stupid Star Wars question. But yeah, we're doing it right. This was 148 plus 256. Star Trek is 182 plus 256. How many people like both? Or if you liked either or. So that one's a little more complicated. So this part made sense, right? So
Yeah, but it's so they didn't want it to be added up.
yeah, just add them up. So this is people that only like Star Wars.
Or then like it would be so the people that like Star Wars
yes.
would be like 4.
Mhm.
That's what it'll come out to.
Yeah. The only issue is this one. This one's harder. The Star Trek or Star Wars. So that means you have to add up all of them. Because as long as they like one of them,
Right.
then you're good. So it'd be 182 plus 256 plus 148. So nothing too crazy. So these here, though, it says how many people like Star Wars but not Star Trek. Okay. So E, Star Wars but not Star Trek. I would say it's just this piece right here, 148. Part E. And F is people like Star Trek but not Star Wars. So yeah.
And then it'd be the 114 from either, correct? On G.
G, yeah, people out here that didn't care about either one.
How many people were surveyed, so we did the math.
Yeah, add all those guys up. So how many?
700 either.
Sounds about right to me. So not too bad, right? Example 2, I think they want us to draw it out. So there's,
It's almost like the same way they had it there.
yeah, so we're going the other direction now.
So they gave us the numbers of what was actually the union.
Yeah, let's figure out what the heck's going on. So the St. Philip's College, right? So got one circle, another one. Oops. So we had math class and English, right? Only 2 of them. Okay. So $250 are taking math class, so 200 are taking English class, 75 are taking both. Okay. Final number of students are taking neither math nor an English class. So I'm going to say this is math right here. This is English. So there's 400 total.
I know this one, the total is 75 for taking both.
So if you add these together, So what's 250 plus 200? Minus 75? Yeah. Because if we assume they're overlapping, right? Like we have in this picture. So then there's 25 unaccounted for, right? So there's 25 out here somewhere. Because 250 would be this entire circle. The 25 is out here. So just for fun, how would we fill in these blanks? So if you want only people doing math, that would be 250 minus 75, right? Which would be 175, right? And 200 minus 75, just English. And these guys would be doing both. So if I add each section, do I get 400? Right. So I think doing it this way makes more sense in my head.
Yeah.
So adding these together, so adding all these, this is less than 400. So total 400. Let's do another one. Example 3. Yeah, it looks like they surveyed 700 people to ask which TV station they watched. PBS found that 125. So how many stations are they talking about? So we can figure out how many circles. That's 2, right? So PBS and cable stations. This is PBS. Let's call this cable. Okay. So 97 say they did not watch any TV station. So that's out here somewhere, right? Did they say how many watched? They didn't say just PBS, right? So it could be both. 563 like to watch cable. Okay, so if we were to add all those numbers, what would you get? 785, right? So that means we have extra. So that extra means we added that inner part twice. So I think the 85 would be the middle. So 85 right? 785?
Yeah, it's 785.
So that excess, because we added PBS plus cable, that means we added it 85 2 times.
Oh, I added 97 too.
Yeah, so I added this one, and 97. You got 785.
Right.
So that extra is the inner part. Because whenever you add 2 sets together, it adds that middle part twice.
Okay. Yeah. Okay. So then we got all right. So 560.
So now
Yes.
Yeah.
No, it's
Cable.
63 like a cable station.
So subtract this, take 85 away from this guy and we'll know only cable. You know, they didn't ask us to fill in all the blanks. It'll help us get used to it. Yeah, 125 minus the middle part. 40. Okay. But the answer they wanted was how many people like to watch both? Yeah, 85. This is the one they wanted.
Okay, well, I go just saying, but it's just getting used to filling. I mean, even though it's not asking for it, but I mean, I go, it's easier to once you fill it in. So,
Yeah, if you fill it all in, you can answer any question. They would have said, how many people like only PBS? Well, it's right there. Right. So the practice is good. Does this one make sense though?
Yeah.
Okay, let's look at 4. The nationwide survey of 900 people. People were asked about their preferences for fast food restaurants. It was a lot of sets, huh? Okay. Let me zoom out a little bit. Let's make my box. Make our circles. We got Burger King, Wendy's, McDonald's. So it's 3 circles, right? Make them bigger because it's too small. Okay, looks pretty good, right? Better than my drawings on paper. All right, so 315 liked all 3. So think, look, luckily they gave us that because we put that right in the middle. Liked all 3. So now 421. Yeah, so let's put that, let's label it before I confuse myself. McDonald's, Burger King, Wendy's.
so we got to figure out. So they said 659, like.
Yeah, 659 like Wendy's. So that's this whole entire circle. That's gonna be like a weird game trying to find the pieces, right?
Yeah, because we also got 421 like Wendy's and Burger King.
So whenever you see that and, that's the intersection. So Burger King and Wendy's would be this entire circle or this little section right here. Right here.
So we need to figure out.
So subtract.
So we got 315 like all 3. So we'll take that 421
Mhm.
minus 315.
Yeah, 421 minus 15.
106.
Yeah, so now we got this piece. Nice.
And then we could do the McDonald's and Wendy's.
McDonald's and Wendy's.
500.
So that's, yeah.
185.
So now we got that piece.
And then no, that was McDonald's and Wendy's.
Oops, yeah. So McDonald's and Wendy's. So that'll be, what'd you get?
185.
So 185. So what you did was you took McDonald's and Wendy's, 500, right? And you subtracted by 315. So that gives me the 185. Right there. Okay.
Find out McDonald's.
McDonald's and Burger King.
So
It's 359, right?
so it's gonna be the whole McDonald's was 641 like McDonald's.
Hold on, we got the 359 right here. Burger King and McDonald's is this entire middle circle section. Yeah. Yeah, subtract 315 from it, and you get 44, right? So now we got all the inner pieces. So now we can take everybody who liked McDonald's and subtract all these sections right here. You got 97? Nice. Burger King is 540. So subtract all these pieces to get this inner piece. 75? Nice. So Wendy's 659, subtract these three pieces. Nine. Nice. Add all these totals. Is it 900? Because there might be some people out here that hate all this stuff. So how many don't like anything? Yeah, the 69 up here say they hate Burger King, McDonald's, and Wendy's. So yeah, got it. So
That's how you use that to answer ABCD.
yeah, I hadn't even looked at the questions, but we use this. Right. Go down here. How many people only like Wendy's? Well, 9. It's right there. How many people only like Burger King? Well, we got that too, 75. How many like none of these? Well, that's 69. How many people like just 2 of these of the 3 restaurants? Just 2 of the 3. Huh. I guess that would be either 44 plus 106, right? Plus 185, because all those guys liked only 2. See what I'm saying? There was like only 2 of the 3. So 44 plus 106 plus 185. So all those guys like 2 different ones. Yeah, 335. They see how once you build the Venn diagram, it's not too bad. Okay, let's see here. Make clear. Yeah, call it here. Sounds good, man. We'll stop here. I'm hungry anyway.
I know I got my other class early and